Now, this problem, for some of you, may look intimidating, but I want you to appreciate one thing about this solution, which is a general lesson about how to attack economic problems and problems in science more generally, which is to stop and think. Now, the intuition of many of you is going to be to start computing integrals like crazy to solve the problem, and you're going to make your life very hard. If you think for a second, if you're lazy and think about what is an elegant, simple solution, this problem is actually extremely easy. Let's see why. So we're going to compare the consumer surplus in two situations, theta 1 and theta 1. Sorry, theta 0 and theta 1. And we know that theta 0 is a situation in which the demand at theta 0 is just basically what we studied before, which is the demand of buying at price P, and we have solved that repeated times during the video lecture, so that is just equal to A squared divided by P squared. And we have also computed before the consumer surplus of theta 0, which is just the consumer surplus at price P, which was equal to A squared divided by P. So that part of the question is trivial. Now here is the second part when you want to compute X star of theta 1 and CS of theta 1, where you want to stop and think. Now, what does it mean to have a tax? From the point of view of the consumer, it basically means that the price has doubled. So the demand, the optimal behavior of the consumer when at price P, when it faces a tax of 100%, is just the demand at a price of 2P without the tax. Notice the notation. This is the demand. This is the demand that we characterized before for the case of no taxes, but at twice the price, because with 100% sales tax, the consumer faces a net price that is twice as high. So this is going to be equal simply substituting in the formula to A squared divided by 4P squared. Haha! Nothing had to be computed that is hard, just with a little bit of thinking. And similarly, the consumer surplus at theta 1, using the same trick, is going to be the consumer surplus that we had before without tax, but with a doubling of the price. And that is just going to be equal, substituting the formula, to A squared divided by 2P. Now, given this, what is the change in consumer surplus from theta 0 to theta 1? Well, it's just going to be the difference between this consumer surplus and that consumer surplus, which is equal to A squared divided by 2P minus A squared divided by P. And this is just equal, doing the algebra, to minus A squared divided by 2P. That's the solution. Now, as always, let's do a tiny bit of check of our economic intuition. Notice that the change in consumer surplus is negative. It has gone down, and that's not surprising for any price, because, you know, now we're paying a tax. We're paying more for the same thing, regardless of the price, so it should hurt us. And the second thing that you should see is that the larger the price, the smaller the change in consumer surplus. And some of you might find that surprising, but the idea is also intuitive, because the larger the price, the less you were buying in the first place, the less the demand. So in some sense, the less amount of good and expenditures on which the tax bites. And if you want to see that in another way, suppose that price was equal to infinity, you would not be buying anything, and the tax really wouldn't matter at all.